In method 1 for simplifying complex fractions, this is where we're going to simplify the numerator, then simplify the denominator, and then divide or multiply by a reciprocal. Okay, so for example A, we want to simplify using method 1. And so the main bar is here. If you look at the numerator part, it's one term, so that's already simplified, and so is the denominator part. So we're going to multiply by the reciprocal. The numerator part stays the same. We change division to multiplication, and then we flip that denominator part, so the reciprocal here. And then this is just multiplication of rational expressions. So we multiply the numerator, we multiply the denominator. So 3 times 5 is 15 times a times b in the numerator. And in the denominator, I'm just going to leave it as 25 times 9 times a squared times b squared. And then we want to simplify by dividing any factors in the numerator that are also in the denominator. So I'm going to look at some prime factorization here, make this easier to divide factors. Okay, so in the numerator then we've got 5 we can divide with the denominator, and we've got 3 we can divide with the denominator. Oh, what about a? We can divide an a factor in the numerator with one of the a factors in the denominator. And same thing with b. We can divide one of those factors with the denominator. So what does that leave us in the numerator? Looks like everything has canceled out, so just 1. In the denominator, we've got 5 times 3 times a times b. So 15ab is our simplified complex fraction here. Then for example b, if I look at the main bar, then the numerator part is only one term, and the denominator part is only one term. So I can just go ahead and multiply by the reciprocal here. So the numerator part times the reciprocal of the denominator part. And so now this is multiplication. I want to lock up factors together and multiply across. So 6x times x plus 5 in the numerator, and 12 times x minus 5 in the denominator. So then I can definitely divide a factor of 6 from the numerator and denominator, and that's it. So let's see. In the numerator, we have a factor of x and x plus 5 left. In the denominator, we have a factor of 2 and x minus 5. So now that we know that this is as simple as this is going to get, we're just going to go ahead and distribute to remove parentheses. So in the numerator, that's x squared plus 5x. And in the denominator, that's 2x minus 10. So that would be our simplified complex fraction. Now example C, this is going to be different because if you look at the main bar, the numerator has 2 terms separated by that subtraction. So first thing we need to do is get that numerator to be only one term, and that means least common denominator. So the denominators are y squared and y. So we need a factor of y at most 2 times. That's the highest. So the first term is fine. X over y squared already has y squared in the denominator, but the other term does not. So 1 over y needs to have y squared in the denominator. So we just need another factor of y there. So that gets us an equivalent expression of y over y squared. And now that they have the same denominator, we're going to keep that and combine the numerators, so x minus y. So that will simplify the numerator part of this complex fraction. Now I need to look at the denominator part and find the least common denominator for x squared and x, which is x to the highest degree. So I know that the first fraction is fine, y over x squared. But then I need to have that common denominator in the 1 over x. So I need another factor of x, which means that that equivalent expression is going to be x over x squared. So now that those have the same denominator, it stays, and we combine the numerators to simplify that denominator part of this complex fraction. Whew. Okay. Now that we have one term in both the numerator part and the denominator part, we can go ahead and multiply by the reciprocal. So the numerator part times the reciprocal of the denominator part. And now this is just multiplication of rational expressions. So we're going to multiply across, right? Make sure you lock up any factors that have more than one term. So in the numerator, we're multiplying x squared times x minus y. And in the denominator, y squared times y minus x. Oh, well, that's interesting because x minus y, y minus x, those are the same terms with exactly opposite signs. So what if I took the denominator's factor here, y minus x, and I change that to negative x plus y, factor out a negative, and then that's going to be the same factor. So let me just rewrite this so I don't get confused with all of this here. I've got a negative times y squared times x minus y. So negative y squared times x minus y. That makes it a little easier for me to see what I'm working with here. So I can divide the x minus y factor, and that gets me a simplified expression of negative x squared over y squared. And remember, it doesn't matter where you put that negative. Denominator's fine, numerator's fine, and front is fine. It's the same expression here.